Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, so this is our second performance task that has to do with our last chapter unit 10.1.5, where we're actually taking applications of volume in the real world kind of context. This one's called rolled oats, and your task is you work for a company, and your company sells this kind of, not Quaker oats, but rolled oats, which, you know, this kind, I'm sure you've seen these Quaker Oats boxes in the grocery store. Basically the same idea. The rolled oats come in cylindrical containers with a diameter of 5 inches. There's a diameter going straight across, and a height of 9.5 inches. These containers are shipped to grocery stores in boxes. Each shipping box contains 6 rolled oats containers, so it contains 6 of these. And the company's trying to figure out the dimensions of the box for shipping the rolled oats so that they will use the least amount of cardboard to ship. You know, if you think about this, when they make millions of these rolled oats containers per year and they have to ship them out, if you just save like a few square inches on every shipment over the course of a year with millions of boxes going out, you're going to save a significant amount of money for the company. And so this is the type of thing where, you know, companies are trying to increase their profit as much as they possibly can. They don't want to waste anything. So your task is to figure out a configuration for these rolled oats boxes and how you can put them together in a box that's going to be a rectangular prism. Notice how it says rectangular prism? You have to do that. That's how they're going to ship these. You know, when you are stacking boxes in the back of a truck and you need to ship them and then you need to stack them so that you can wheel them into the grocery stores, you can't have these odd shaped prisms for your boxes. They've got to be rectangular prisms. So that's your only option here, nothing else. So how can you configure 6 of these in a box that will give you the least amount of surface area? That is your task. And so just to give you an idea here, if you were to put them side by side and had your box look like this, you would then have to figure out, all right, what would be the dimensions of this box? So if we have 6 of them lined up in a row, this box would be 30 inches long. At the minimum, it would have to be 9.5 inches tall, but some students, to make the calculations easier, have decided to make the box 10 inches tall, figuring maybe it's not the smallest, but at least it'll be easier to work through the formulas. But honestly, I mean, you should, you know, I think this would fit in a box that's 9.5 inches tall, and that would reduce the amount of surface area. So you should probably stick with the 9.5 inches as the height in this situation. And then since it's a circular, you know, shape, this cylinder, if it's 5 inches going in this direction, it must also be 5 inches going in that direction. And so this would result in a cardboard box that ends up being 30 by 9.5 by 5 inches deep. Figure out what the surface area of that is and figure out what the volume is. Then change the configuration around. Can you stack 3 on 3? Can you have 3 in the front, 3 in the back? What are some different ways that you can configure all of these and figure out what the dimensions of those boxes would be, and do like 3 or 4 different configurations, because there might be a configuration that that is actually the best answer that you don't find if you only decide to do 1 or 2. So try and figure out as many different combinations as you can get. And your task, once again, is to draw the picture, show me what that configuration looks like, show me the dimensions of the box, show me how you came up with the surface area and the volume for that box by showing your work. And when I say show me, you're not going to actually turn this in. This is kind of like an at-home activity. But I will go through and I will show you some different configurations, and I'll show you some of the different answers. And then I'll tell you what the best answer is for A and B, and see if you got the same thing. Okay, so This one should not be as complicated as the glasses task. This is typically one where groups get this done in one day in a class period. And I don't know that, you're at a disadvantage by not having your group with you. I think you could probably figure this out a bit. Now I'm going to turn the page and I'm going to show you another configuration just to give you two. So here's one. Here's another way that you could present it, right? If you had 3 in the front, 3 in the back, draw what that box would look like. Show me the dimensions. This would be, in this case, 5, 5, and 5 is 15 inches going from for the length. Going for the depth, because it's 5 and 5, that ends up being 10 inches. And then the height is, once again, 9.5 inches. So there are a few different configurations you can make. Try and find as many of them as you can. And good luck with it. And I will actually, unlike the glasses task, I'm just going to tomorrow, I will put out a video that shows what the answers are. And you can see how well you did. All right. Good luck.
Hey, feeling good, like I should.